Hello, everyone. A very warm welcome to another Kaizen Central on Zanut TV. People are joining us as we speak. Looks like another busy meeting, and it's wonderful to see everybody. It's been obviously a week of added uncertainty around things like unemployment and all of that, and coronavirus. I don't know if anybody has started to take extra measures, worried about a second wave, but obviously these things are deeply worrying, and just at a time when we have to start thinking about the possibility of a no-deal Brexit. So it's been tough for a lot of folk. I hope it hasn't been tough for all you good people on the screen. Welcome again, some new faces, some old faces, and glad to see Richard just joined us from Rochdale in Lancashire. Hello, Richard. Steve, hello again. Whereabouts are you from, Steve Edge? Where are you from? Whereabouts in the country? I've forgotten, sorry.
Not far from Lancashire. I'm just South Manchester, Cheshire.
Oh, okay. All right, cool. Mark Weymouth is not in Weymouth. Whereabouts are you, Mark?
So near Worcester in the Midlands.
Ah, terrific. So, and Angela, you're Midlands based as well, aren't you?
Sunny Sutton Coalfields, and we also come under Birmingham with the new COVID measures.
Okay, well, listen, we're going to be joined fairly shortly by John Worrell from, fingers crossed, from Proto Labs, who were the manufacturer of the week. But I'd just like to, when he comes in, and we can have a discussion about some of the technologies they're using. But I wonder if anybody's got anything they'd like to throw on the table to discuss. I need the password for the room. Okay, sorry, this is him now. Anybody that got an issue they'd like to discuss? So please, I throw it open to the floor.
I think, Nick, in your email you sent out earlier, you referred to an article that you put on LinkedIn, talking manufacturing's not dead and about appealing to the younger generation. That's something I've been giving some thought to over the last week or two. And funnily enough, I met a lady a couple of weeks ago on a networking event who she goes into schools and gives career guidance. And I've actually set up a Zoom with her Monday morning to pick her brains and to find out, how manufacturing features in that. So I don't know if anybody else feels the same, whether that would be a good point to discuss.
Can I perhaps just give some context around that? It was an article that provoked a significant amount of discussion and views. I mean, I had hundreds of people read it, and at least 200. I mean, Jürgen Meyer reposted it, which gave it a much bigger audience. But it basically said that because manufacturing has left towns and cities, back in the day there used to be mills and shipyards. I used that fabulous picture from Tyneside, where there's a ship sitting at the end of somebody's street, and I actually had people commenting on the article saying that they used to live on that street. It's quite remarkable. But it was basically about the fact that part of the reason why manufacturing has left the national consciousness is because it's invisible. It's on business parks, industrial estates. It's no longer in people's line of sight. And rather than keep trying to impress at a national level that manufacturing is here and national is too big, local communities are where it has to happen. And surprisingly, I've got a tremendous feedback from people who said, well, we're already doing that. Like there are cooperatives there's a cooperative down in Plymouth, for instance. I know in East Anglia, there's Norfolk has got one going. Oh, hello, John Worrell's joined us, terrific. A number of people have got initiatives like this where they are gathering together. You don't have to feel alone as a manufacturer in this. It's not like, oh my God, does this mean I've got to get in touch with schools? No, you can get together with a number of other manufacturers, start these cooperatives, have things like open days, hire a bus and take school kids to various factories on an open day, lots of things. And it was really just a call for manufacturers to get the messaging out at a local level about the vibrance of modern manufacturing and its brilliance as a career, because heavens above, we need people to join the sector. Good evening, John Worrell from Proto Labs. How are you?
Yeah, good, thank you. Can you hear me?
Yes, perfect. And I'm so sorry. This Zoom thing is just really beginning to tick me off, because it's supposed to be a one-click wonder where you don't need the password. But anyway, there we go.
It was an admin rights issue on my work's laptop. It wouldn't let me download it.
Oh, I see. Okay, all right. Well, listen, John, I'd love to chat about Proto Labs in a second, but I was just talking about an article I posted on Sunday about the need for manufacturers at a local level to become much more active and cooperate with each other to get the message out about manufacturing, because it's at the local level that it's become invisible. It used to be, you could see, where people used to work, from the mines, the mills, the shipyards. All those have gone, and people now think manufacturing itself has gone. And that's why manufacturing at a local level needs to say to its communities, hey, we're here. This is where the jobs are. It's not just in the retail stores or in the services where young people naturally sort of come across them every day. They need to see, where they can't see manufacturers need to place themselves front and center and make themselves more visible. Has anybody got any thoughts around that, or has anybody got any other initiatives? Because I actually want to collate all these initiatives and put another article up to sort of start to get a bit ahead of steam around this, and maybe put it on our website.
No, I would agree. From the manufacturing engineers, my manufacturing engineers, we do struggle with sort of numbers of tool making engineering companies, general machinists. We don't do a lot of manufacture in house of our own jigs and fixtures. We outsource those just because we don't want to take the capacity away from the customers. And we do struggle with general sort of jig and tooling, specifically manufacturers local to us. We tend to have to go quite far afield, and getting a good service out to the local ones does come at cost, really. And I think it's important for the younger generation as well. Myself, coming from a background of a tool making engineering apprenticeship, I think it's really good, really important for the younger generations coming through to get that sort of background in that sort of industry.
Nick,
yes,
I wonder as a sort of non-practicing manufacturing person, whether when we all describe it as manufacturing, the young people that we're trying to address and engage actually even understand what manufacturing is. So, it's a general term, but there's so many different things that are done within that overall term, some of which will be very exciting to different people. So maybe we should be thinking about the more specific aspects of what manufacturing is and what it can involve, and use that as a way of introducing people to it.
Well, can I throw that back at you and ask you perhaps what come up with a suggestion? What do you how would you describe it? You mean make it more about some of the digital technologies, et cetera?
Just, if you say to a 15-year-old kid manufacturing, they create, I'm sure there's a picture in their head. It may be a very blank picture, but it's not like it was, in my generation when I was 15, somebody said manufacturing, I'd have an idea. There was a mill, there was a factory, there was at least some idea. So if you talked about, I don't know, for example, robotics, so you could get involved in, making robots make things, or, it's about, the practical skills that a lot of young kids have. But in school nowadays, they just don't get to be able to use those skills. So they're not, there's a load of kids, there's always been a load of kids that were not academic. Where do those kids find their way to manufacturing jobs these days? Yeah, I don't. It's a question. I have no idea.
We discussed this on previous programs, it's damn difficult because the schools don't know much about it. And getting access to the schools can often be difficult. The government has set everything up to for people to go to university. Further education receives about 25% of the per head funding that higher education receives. The deck is stacked against us. This government, one of its virtues, and I'm not certain how many virtues it has, but one is that it genuinely wants to improve further education. I can only think that's a positive. Angela, sorry, were you raising your hand there?
Sorry, Nick. Just going back to your original comments about manufacturing moving out of town. I think maybe one of the things that should be considered is if you're looking at school leavers to go into manufacturing, obviously they're not going to be learning to drive until they're 17, 18 if they're lucky. And we need to think how accessible are manufacturing sites that are out of town now to the youngsters. We all know youngsters are lazy. We were all there. We've all been lazy teenagers, you know. And Richard's shaking his head. and a lot of kids of that age, they want the easy option. So I think that's one thing. And I think the other thing is JLR, obviously, as I say, I'm in Sutton Coldfield, and my nearest site is Castle Bromwich. And it's right in the middle of housing estates and factory units. And we regularly, when I was working there, we regularly had groups of school children being shown around the facilities. And I think that was a great initiative. But again, I think it's because it was within suburban areas.
Yeah, it was funny. If you go to Siemens Congleton, that's another place. It's actually surrounded by houses, and they can't expand. And because they can't expand, and because they need to survive, it's been like a pressure cooker, forcing them to become ever more efficient and more productive. It's a great story. Yeah, I take your point absolutely, Angela. We've covered education quite a bit on these shows in the past, and it's an ever-growing and ever-worrying issue as as we need, was it 25,000 qualified engineers every year? I mean, it's just a hideous challenge for everybody. But I'd like to move on. Let's say John has joined us from Proto Labs, and what really struck me about Proto Labs, if you haven't seen the program, is that in 1999, this very clever computer whiz and entrepreneur, Larry Lucas, in the United States, was horrified at how long it took to get things prototyped. So he decided to go digital at a time when people didn't really know what digital was, except maybe it had something to do with a computer. And John, from that moment on, Proto Labs has probably been one of the most digital companies of its kind in the world. Am I correct to say that?
Yeah, I would certainly say so. Like you mentioned, from those very early days with Larry Lucas, really taking on board the digital thread idea, and he went into the local universities there to develop the programming that we still run today. The basis of the programming that is still there that we run today. And yeah, everything that was by Larry to start speed the whole process up, taking that very first CAD model that you upload as a customer, as a designer, right through to the sales side, through to the design side, through to the manufacturing, and right through to the end of shipping. It's all controlled by the software. From the manufacturing side, the speed element there is really designed about very standard processes. I like to refer as our manufacturing facility, although we're producing molds, bespoke molds every single day. I like to refer to it as a production line. We have to have those standard processes to work to for the guys on the shop floor to work to be able to produce so many molds on a daily basis. So yeah, the digital thread gives us that time, takes the time element out of the customer facing side, gives us that time back into to give us that time to manufacture the actual, whether it be the molding side or the CNC part side, or even the 3D printing side.
Because you guys went in. You guys went into 3D printing heavily about 6 years ago. Now, correct me if I'm wrong. I don't know whether you felt you were ahead of the curve on 3DP then, or whether everybody else was going as quickly as you.
So I only joined the company 5 years ago. So it was just at the sort of very start of Proto Labs getting into the 3D printing side. I don't know the time element around the US launching the 3D printing side, but you were right in saying that in the EU we launched 3D printing around 6 years ago. I think that we probably did think we were ahead of the game at that time that we did launch it. Looking back, I don't think we really were. But what we do today is heavily invest in the more unusual materials offering. 3D printing isn't my forte by any means. The Proto Lab took 3D printing out of the German manufacturing site. But I know we heavily invest in design and technology and the latest equipment coming through. And because 3D printing is very quick as a manufacturing technique anyway, we look at the more specialist materials that aren't so readily available by other manufacturers.
Anybody got anything? Adam, you work with 3DP, I'm correct in saying? What do you have there? I need to change my speaker view.
No, you're on mute, Adam.
I've just muted myself, so yeah. I forgot to. It's an aerospace model. I have that as a demo. We did it for an aerospace company, but it's about 1/10 the size. So
I see.
It's prototyping, but that's where it comes in. The prototyping side is that from that company that we were dealing with there, we're on a 7-8 week lead time to have it machined, and about an £8,000 cost, and we did it in sort of like 72 hours. At like a cost of about £450, because the engineers want something in their hands to look at. So that's it really comes into its from that point of view. But we do production parts as well for businesses. Generally small batch, generally legacy sort of like parts is where it hits, because they can be some of them long lead times. But yeah, we find it fascinating, but frustrating at the same time as well. It can be so frustrating.
Well, my conversation with Peter Richards on the program was interesting for a particular reason. Obviously, aerospace and aviation, John, are big sectors for you guys. And I asked about the aerospace in particular, and he said that Proto Labs have done this research, and the COVID thing has obviously swiped everybody, sideswiped, and yet it is accelerating research into lightweighting and everything else, because they've got to find new ways to get ahead of the game. I don't know if you're involved in that, John, on developing those new technologies for aerospace. Were you involved in that research?
I wasn't, to be quite honest. So our R&D department sits in the Americas. We are looking at the aerospace sector, as Peter says, and looking at what we don't offer as a company and what we need to do to start breaking into the aerospace sectors. We are a prototyping business, and we're starting to really sort of branch out into the other sectors with higher tolerance parts and things like that. The basics that we do today that we serve us so well with prototyping companies, we need to branch out and increase things like tolerance of parts and surface finish and documentation around it as well. But no, I wasn't involved specifically in the into the aerospace discussions.
Stephen Barr, hi. Have you, you as Edge Digital Manufacturing, you obviously talk to a great many manufacturers. Does the prototyping end of the spectrum, do you ever get involved in discussing that, or are you, when you're discussing applying digital technologies to businesses?
Yes, absolutely. I mean, it's among the top 10 technologies, to say the least. I mean, bearing in mind the size of these outfits, so one of the key things that comes up in conversation is, how do we get value for money out of it? But 3D printing, I think, is something that has helped a lot of businesses move forward. And that's why it's lovely to hear stories from people like John as to the kind of technologies that are almost sort of no-brainer investments for businesses, obviously of a certain type, overcoming key challenges that would otherwise tie up people's time. So one of the most surprising companies we've worked with fairly recently is Darwin Terracotta, obviously up by Darwin in Lancashire, making really high quality architectural cladding, but they had just one sculptor in the business who did all the sophisticated stuff. And actually he was the one who recognized that if he could make molds using a 3D printer, he would make himself free to do the really classy stuff that artistic stuff that he really wanted to do. So you see that sort of inspiration coming through, and the business case wrote itself for that kind of activity. So yes, we find 3D printing and other really obvious digital technologies are the ones that allow companies just to get a taste for how data and digital can make a difference to them. Obviously, John Worrell is sort of living embodiment of someone in a business that has really taken that on board to a very high degree.
Roy Howarth, you're in your car. Where is your daughter? Is she playing football or basketball? I've forgotten.
Hockey.
Hockey. Okay. Oh, well remembered. Well remembered. Roy is with Airbus Defence and Space. Does 3D printing enter into what you guys do, or is everything made straight from the CAD drawing?
No, absolutely. We're definitely utilizing 3D printing more and more. So the thing that we had to get our heads around was the material properties, because obviously we launch things into fairly exotic environments, and in order to ensure the long-term reliability in those environments, we have to really understand the material properties and the fact that when we make it once, we can make it multiple times exactly the same quality level. But now we're using it brackets, some fairly critical brackets that are antennas, and if they fail, then you lose the satellite. We're using it for a number of different things on our military aircraft, things like engineering leaks and other products, and it's just growing. We're just actually looking at the moment in terms of polymer 3D printing to replace some metallic brackets with polymer brackets. So yes, and it's really appealing to us because we're low volume. So, we don't have to make big stocks of things or buy big volumes of them. We just make them to order when we need them. So there's a lot of attraction, and particularly in where I work in Portsmouth, we've got a lot of waveguides. You saw them when you came and visited us, Nick. Routing signals, high frequency signals around payloads, and these are traditionally brazed components, aluminium components, and we're just beginning to use 3D printing to make certain parts of those where we need to more densely pack them. So there's a schedule reason, a cost reason, and also now a technology reason that's pushing us in that direction.
Is it an absolute truism that 3D printing can only be for low volume? Is there such a thing? Is anybody doing any high volume 3D printing? Does anybody know? Is it a thing?
I've got an interesting story, because during the early days of the COVID, we decided that we wanted to contribute some way, and certain parts of Airbus with the ventilator challenge, there was nothing much we do there. But we started looking at face visors, so acetate sheet and a piece of plastic, and we looked at lots of people making them, doing 3D printing. I think the guy who did the design for us, he calculated we could make something like, I can't remember what it was 15 or 20 per hour on a certain sized print bed. And we decided to go down inject molding route because we could make 10,000 a day. So I think it all depends on the product, the application, and the material. And sometimes traditional methods will still win.
Yeah, I think there's no doubt about that. No doubt about that at all. Richard, Crystal Doors in Rochdale. Do you ever use any technologies like 3D? Would it have any application in what you do?
We're into subtractive manufacturing, which means we take things away from things like the MDF. So obviously we're now talking about additive manufacturing, which is where we're adding things together. And yes, the 3D printing world has taken off rapidly. I did a patent in about 2000, which was to pocket out an area of the MDF, put an epoxy resin mold in, which was a fancy shade, and then wrap it. Got the patent, and obviously the kitchen market went into plain slab doors. So my great patent was never taken off. I'm still working. I've worked with Made Smarter. I've done a lot of research to try and get a wood-based product to be able to make up a door. The difficulty is as you build up the layers, they say there can be difficulties with delamination between those layers. And obviously within a kitchen or within an environment like hospitals and prisons that we put our products, there could be issues. So I'm still looking at it. The other one was to try and make a window frame. There is a window company that makes circular windows and shaped windows, which outweighs wanting to do that compared to the straight windows, which are as straightforward as the standard machinery. Then thought, can we vacuum it? And you can't, because once again, you've got this delamination between the layers. So there still is a long way to go. You're right, at the moment, the one I was after was 2 heads, so it could change from nozzle sizes. But what we're looking for now is a bit like the printers in ink. They've jumped up in absolute great volumes to now the speed that they can run, because they've got so many heads. And I think it'll be the case with the 3D printers. When we've got 50 heads on it to do a multiple, then we'll get up to see the volume. But it is exciting times, and yes, I'm on the edge. I keep on looking, but can't get any real purpose yet.
Well, one of the things that I raised with Peter Richards during the video was the LASIM project, which is an EU-funded project, which Autodesk are very, very much into. It's actually a combined additive and subtractive manufacturing machine. It's a hybrid. And I was asking whether that would have any application for Proto Labs, and he would say, well, probably not, because you've got to look at ROI and time and downtime and all that kind of thing. I think, John, you need to keep your production line running as swiftly as possible. You can't afford any downtime. But I thought this was a very interesting machine. Can anybody think of applications where, I mean, this would be metal additive manufacturing, where you'd actually print the thing and then CNC mill it all in the same place? I'm just wondering if anybody thinks there might be an application for that.
When we were looking at, when we first got into 3D printing, one of the things that we did was coming from the blade and vein side of what we were doing. So there was some machining in that side. we were actually walking around, I think it was Mac, and I said to Richard, who was a sales division sales and marketing director, wouldn't it be good if we could actually get a 3D print and machine at the same time? And we actually walked around, asked people, and we found one machine at Mac. It's only about 3-4 years ago this was, and it was all, they didn't have a machine there, it was just up on a shelf, a brochure, and they showed us. And we were saying, yeah, there's a definite application as to where you build the intricacies, and then you need the precision, so you machine and then you build again, and then you machine again, and then you build again. The absolutely definite application for it, because we were looking at it years ago.
This is it's LASIM. It's spelled LASIMM, and there's actually, the website is lasim.eu. Really interesting. The videos I mean, it's a big thing. I mean, it's got two giant robots operating these things, and indeed it is milling by robot. It's all robotically controlled. It's a fascinating piece of kit, so do go and have a look at it. Hello, Helen, thank you for joining us. Hello, how's your week been? Oh, we got bandwidth issues, Helen.
Yeah, busy budgets. Anyway, it's good to hear.
Okay, so yeah, I'm sorry. I think the sound came across rather like a sort of early 1960s Moog synthesizer, which I know that given that's the kind of world you move in. Right,
Nick, a quick one on the 3D printing.
Yes, of course.
I know for a very long time Rolls-Royce have been making turbine blades using a single crystal method, and it contains a ceramic core, which is the mechanism by which they put a very complex set of tubes inside a single crystal blade, which is stunning. I happen to have one of these on my mantelpiece, but that's another point. What I don't know yet is, and I know that very, very fine 3D printing methods are being used to create these cores. What I don't yet know is whether Rolls-Royce are actually applying that technology in their current production, or whether they've got it planned. But it would certainly, to me, look like a pretty good application. And given that each engine has got an awful lot of fans, an awful lot of turbine blades, because they're the little ones, they're these, they're only this big, and that would be not necessarily a mass production operation, but it would certainly be significant levels of production.
Yeah, I went around JJ Churchill, and Churchills make a lot of. They're making these are the hot end of the engine for these the turbine blades, and they're making them for Pratt & Whitney, for Safran, for Rolls-Royce, obviously, and it was fabulous watching them being made. It's a heavy duty business. Who haven't we heard from? Tristan, do you want to tell us a little bit about what you do and how you fit into all this and what you want to get out of it, I suppose.
Okay. So today I had my my recording hat on. I was trying to set up some interviews, but we'd take the kids to the doctor instead. So I do the Cliff Notes podcast, so sort of digital transformation, sort of intersection of digital and manufacturing. So I've been doing that for about 3 years. And then, when I'm not doing that, work with some startups, and my main bit's the agency for manufacturing companies. So we do web applications and more integrated applications for people.
Cool. Okay. Can you maybe in the chat box just put a link to your podcast? It'd be great to for us to have a look at that. Thank you. And Alec, welcome to you, sir. How are you?
Yeah, apologies for my lateness.
Oh, it's quite all right. Alec is in he's transforming the world rice industry, and that is a noble task. Tell us how you're doing it, Alec.
We sand rice for a living. It's not very technical, is it?
You do what?
We sand rice.
Sand rice. What does that mean?
So we use abrasive sandpaper belts to take the surface off the rice very gently without breaking it. and very low power. But we do use 3D printing, interestingly enough.
In what form? What for?
I just happen to have a bit here. So we make experimental parts. I think the question mark over production versus experimental is a long way to go before it's a production ready technology. I'm not entirely sure I'm ready to fly in a plane that's been 3D printed yet. You know, if a ice chute falls off my machine, it's not going to kill anybody, but it's a long way down from 39,000 feet, you know. But it gives us opportunities to rapidly test. So for instance, we fabricate our milling chambers to try and simulate the shape that we want as near as we can get with the regular fabrication methods. When we 3D print, we can actually 3D print any shape we want. And then it gives us an opportunity then to determine, is there any value in trying to create that shape by conventional manufacturing processes for production runs, or is it a marginal benefit or no benefit at all, in which case we could spend a huge amount of money on tooling to find out we haven't really gained anything. So as a quick way of finding out whether something works or not, it's been really good for us. Although I have to say I've been pleasantly surprised by how long we just use regular PLA, and it's pretty robust even, and you know, we've run many hundreds of hours of test parts, and it's surprising how well it lasts. We're just about to start moving into carbon fiber impregnated nylon, which they're saying is that we use a MakerBot Method X, which is really a small printer. It's not, but it's sort of maybe what we would call a crossover. It's not an industrial printer, but it's not a home printer. We had previously a Z18, which was much bigger. What I would, excuse me, I forget who said something about 50 heads on a 3D printer. I was just going, oh God, one's enough. We've got 2 on the MakerBot, and I can't try to get 50 to feed, because the most frustrating thing about it, some of these prints will take maybe 30 minutes, 30 hours, and you'll be 29 and a half hours into a print and it'll jam. And you got to start again. So it's not a perfect science, but it's been really fun for us.
It's one of the most frustrating things out, in my opinion.
We've all been there, but you know, I think on the upside, I mean, and again, somebody mentioned earlier, for a long time I wondered, is this a genuine tool or a boy's toy? You know, and I hummed and hawed for a long time, but we borrowed a printer to begin with from one of our project partners, and it proved incredibly useful. And so now we've invested in it. It's a smaller one, but I've got it at home, and there's limits to what my wife will put up with. But of course, working from home, it's perfect right now, because we can do R&D from home. We don't have to be in a factory, so it's kind of perfect.
Ram at Equitas Engineering, do you do any 3D printing? Does it enter your operations?
I was hoping you would ask, Nick. As a product development and engineering solutions consultancy, we use 3D printers to do prototypes. So this one is a lightweighted bicycle rear hub, I think dropout. And then this one is the 3D printed prototype of a breathing device that we developed for a client, which helps prevent death by choking when connected to a ventilator pipe or a breathing machine. So we've 3D printed both these components, and we've tested it with a standard, what is called as a 15F connector, with the springs and everything, which is inside one of these cavities here somewhere. So it's inside here, and it actually works. So we've been able to 3D print and test and validate the design. So CFD gave us the pressures and the forces and everything. We printed it and designed it according to the CFD results. And now the real life test data shows that it works. So we're using 3D printing to validate what we do on the design and analysis side. And so far, we seem to have struck gold. Fingers crossed, touch wood. So
hey, Proto Labs, you've got these guys breathing down your necks. These Equitas, I don't think you're quite on a global scale yet, but it's good to see. It's good to see that, you know, there's so many really, I don't know, intricate and imaginative and creative ways in which you know, SME companies are using these technologies. I think it's really exciting.
I'll just add there. I've just sat, as I'm sat here now, and my setup around me, I've actually looked at how much 3D printing I've actually got around me that's enabled me, because I can think of it and because I can draw the shape. So even down to cameras and holding the camera angle, and because I can print it, I've got 10 pieces of 3D printed. My laptop that's up right here now facing me is on a stand that I've 3D printed. The camera in front of me is on a stand of 3D printed. There's a camera at the back that is on 3D printed when I want to do one from the back. So it's loads. If you can think, you can draw the design, and the 3D printer can cope with it, then yeah, as an engineer, it gets you thinking differently in engineering it. And that's the key thing for me. It completely changed the way I thought. And we got into it because I was seeing aircraft seating where the arms, and you'll see it, and it when you look at them, they're just like all like a tree when they've done it for lightweighting, and it's all 3D printed. It's all metal. So it just changes the way you think totally. It's fascinating, the process.
Stephen Barr.
Just thinking back to that conversation we were having earlier on, sort of kicked off by what Angela was saying about going into local schools, I think, aren't you, Angela, to talk to school children, or at least thinking about that as an idea. And I wonder whether 3D printing, mobile 3D printing, is something that would really help with getting the opening up the eyes of school children to the idea of manufacturing as a really interesting, really exciting thing to do. I was lucky enough just before COVID to go into a school. I mean, I'm a civil engineer by training. They weren't that excited by the idea of concrete mixing, I have to say. But something like 3D printing might just grab the attention.
Well, there's actually a machine. There's actually a machine where you change the heads, where you can router, you can create a PCB board, and also 3D print with interchanging the heads. You could, and they were actually building a drone. So they could actually build a drone from one machine, and it was at the 3D printer show, and I forgot what it was now. Only not last year, year before, and it was absolutely superb for schools, and that's the target market they're after, because it just swapped the heads out.
I actually went into my eldest high school to do a talk. I took a load of parts, 3D printed, injection molding, CNC machined. And the marketing equipment was lent to me, and the kids, I got some excitement around it, but it wasn't the machine part, it wasn't the injection molding, it was all about the 3D printing. That's what they wanted to know, and that I do think local businesses, that's what we need to do. We need to get into schools, universities, and get that sort of excited. And we're talking about it today, and we're getting excited about. We can see it, we can make it with a 3D printer, and that's what we need to sell to the youngsters today.
Mark Weymouth, Toby joined us. Your son Toby joined us a couple of weeks ago. It was real pleasure to see him. Just for anybody who wasn't on that call, Toby is I think he's 17 or 18. He's doing A-levels anyway, and he was on asking about whether automation will kill jobs as part of one of his research projects. Now, has Toby run across 3D printing? Is it part of the world he's done? He's done the JLR challenge and all sorts of things.
Toby's probably an interesting example or a timeline for 3D printing. So Toby's 17. So 17 years ago, I was in automotive, and I remember driving 200 miles to go to a special boutique manufacturer to get some 3D printed clips made for automotive, spending thousands of pounds, of say, driving hundreds of miles. Downstairs in the workshop, we have a MakerBot 2 head printer, and Toby prints all sorts of things. He just thinks it's no different than using a calculator. Interestingly, at schools rushed out and bought lots of very basic 3D printers, which they were probably missold and told would do everything. 3D printers are quite hard to use, and the classroom is full of kids who don't think much of 3D printing because they get given maybe 20 minutes to use it. It doesn't work properly. They're locked away by the school because they're not reliable and robust. So you have the enthusiasts who love 3D printing and 90% of the school population who doesn't touch it because it doesn't work properly. So there's a danger in a way 3D printing's perhaps been missold to the schools. However, with the recent COVID crisis, I think everybody now almost takes 3D printing for granted. But certainly the younger generation, yeah, it's just a tool. It's no different to all the other tools. I'm old enough to remember it being an expensive tool.
Some of the things I've seen, BAE Systems have shown me some stuff, and what I don't understand, and I think Adam, you were referring to the seat arms, which just look so different from anything that's just been cast or whatever or milled, and it's just the way that there's almost this science fiction or otherworldly shape that you can get from 3D printed materials that have all the strength and yet a third or quarter of the weight. And that's what's fascinating to me. And I don't know, is it the software that develops? How do people come up with these shapes? Does anybody know? Ram, please.
So hi, so I've used this piece of kit called Generative Design, which is part of Autodesk Fusion 360. And the beauty of doing it is all you are specifying is where are the loads acting on your end component, and at what point is the end component interacting with the rest of the assembly or the exterior world, and what is the material you want your end component to be made out of, and what are the manufacturing methods. That's all you specify. Click the button, it runs through tons of iterations, 100, 200 iterations, generating all sorts of weird shapes and sizes for a given safety factor, for a given cost, pricing, material, weight, what have you. For example, this one, right? That's how we did it using generative design. And if I show the original design, it's a chunky piece of metal. But this one has got all these beautiful, what I like to call as biomimetic design, where it tries to resemble nature as closely as it can. That's what it does. And then you take one of the outcomes, and then you maybe refine it a little bit in your CAD, do some proper old school FEA, do some static fatigue analysis, whatever you want to do, and then refine the base design. You're not going to be doing sketches, build up a part, do an assembly for some of these components. You'll still do it, but that's how this works. AI does all the hard work for you, but as an engineer, you still use your intuition to determine where your loads are going to act, what the loads are going to be, where it's going to react with the external world or the other components, and then let AI do the number crunching bit.
Wow. Well, there's a nice testimonial to Autodesk there. Thanks for that. So what was that word you used? Biomimetic or biomimicry?
Biomimetic design, yeah, where your designs resemble nature as closely as they can.
And that really does sum it up for me, because it is like that. When you look at the arms on the aircraft, it is like a tree, the way it's done. And it is just like nature would have it. It is phenomenal. That's a cracking way of describing it. Cracking.
Something like out of Avatar or something like that, you know, these strange shapes. But yeah, absolutely. So John Worrell, generative design, I imagine this is bread and butter to you guys.
Yeah, certainly. There's certainly from the 3D printing side over in Germany. Yeah, it's sort of second nature. Yeah, the guys over there that we acquired the company in Germany. It was a company called Fineline 6 years ago, and we acquired with that some really skilled engineers over there.
Mm. Okay, we've got 10 minutes left. Anybody else got anything they want to throw on the floor? Have a chat. One thing I'd like to throw out there, I've had an incredibly frustrating day. You know, I do this manufacturer of the week thing. Richard very kindly has been the subject of one a couple of weeks ago at Crystal Doors. It's as hard as hell to get people to volunteer to be interviewed. To be the manufacturer of the week. Now, Ram and I are in discussions about doing Equitas in the near future, but we're hoping to get Autodesk involved in that as well, which is why that's still a subject under discussion. John, of course, from Proto Labs was manufacturer of the week this week. But I put messages out on social media, LinkedIn. Why doesn't anybody want to do this? Anybody got any ideas? Alec, would you like to be manufacturer of the week?
I have a face for radio and a voice for print.
Alec, I was going to say, you must do this. You've got some fabulous ideas and technologies. Go on, you owe it to the manufacturing profession.
Yeah, it's maybe a little premature. I mean, we haven't achieved as much as many of the other people you're featuring, but yeah, we're game for a bit of exposure.
Well, we'll take that one offline. I may have won that one. But anybody got any ideas about why, when offered the opportunity for very little investment in terms of time, and maybe 40 quid to buy a bit of kit that holds the that enables a kind of semi-studio-like performance, it's why people just not willing to do it, not wanting to do it.
I think I've said this a few times, particularly on Adam's Manufacturing Hour, where people have commented about, we need to get manufacturers out there talking about manufacturing. And I've said, I can't even get them to talk to me. I think they're a really difficult egg to crack. I really do. And I take my hat off to you, Nick, for trying it.
Well, Tristan, of course, a Venn diagram would have us overlapping quite a bit, I think. How do you find it?
Yeah, I think it's slowly improved, but I think there is the sense of, compared to getting American guests on, in the UK, people feel like they need to have prepared a presentation. I feel like in America, somehow they're built in with the education of how to sell themselves a little bit. So they already have a story they want to tell. In the UK have good stories, but they don't feel like they could tell a good story. And I think some of that's going back to the education piece. That's one of the key things of everyone having to represent themselves and have multiple careers and multiple streams of income. They need to be able to sell themselves and sell that story, not in a way that there must be a sale, but just to relate to someone else and handle it over. So I think that took away a lot of my early things of getting people on the show were them going, oh, well, I haven't got any slide deck. I haven't got any presentation. And that's one of the reasons why I just say, okay, we won't do video for the calls, because as soon as you put video on, people think, oh, I've got to present, I've got to prepare. So maybe Adam has similar.
No, go on, Rob, you go first. You go first.
Yeah. On this matter, Nick, I think it boils down to the culture of how we are as people. I did a TEDx talk last year about transformation from one culture to another, growing up in India versus coming to the UK. And I think it's embedded in how we do things. I mean, for example, if you meet somebody in America, they'll say, how are you? Whereas here we go, are you all right? As if there's something not right with somebody, if that makes sense. And then we might be doing absolutely fantastic. And we then say, if somebody said, oh, you're all right, we say, not too bad. I mean, how bad are we doing if not too bad? So we by nature are very modest and very down to earth in the way, like we don't like talking about ourselves. So maybe that's how we are as people. I think it's in our nature to not talk grand things about ourselves. So it's not a bad quality to have. I know you're struggling, Nick, but so.
I think some of it for me as well is probably two sides. Manufacturing, we like our four walls and we like to make product and we stay within that. And we like making product and it goes out. And I think some of it is an understanding of around the sales and marketing side is that, how can I say, the importance, because there is an absolute massive importance of being seen, being visible. It helps, to coin a mate of mine, Paul, he says you've got to stay visible to stay viable. And there's that marketing aspect of it. And I think, again, it comes down to being comfortable in the, in front of the camera, but getting out your comfort zone. People do think, oh my God, what if I say something wrong and it hurts and things like that. It's just, I think there's a whole host of things in it, but manufacturers like manufacturing.
Oh, look what Roy has shared with us.
I thought I'd just show you that, so it explains a lot of what was being said. This was generated in a CAD package in CATIA, but exactly the same way. We told it where we needed to bolt it down, where the antenna needed to go, what all the loads are, and that's what it came up with. And then we took the original design that the computer came up with, and then put it through the stress loading that we needed for everything. And some of those little beams and things had to be beefed up here and there where we needed a bit more margin. But before, that was a 35 piece part aluminium bracket that was square and boxy, weighed twice or three times as much as that, and took a couple of hours for a guy to assemble. So
wow,
it really cuts down on process time. And of course, we only make one of those brackets per satellite, so we just make one every time we sell a satellite.
That's great. Thank you, Roy. That's lovely.
Nick, on that talking about yourself thing, the comparison with America is, I think, very helpful, because in America, one of the other things that people tend to do very early on in any conversation is, what do you do? Whereas Europeans tend not to ask, what do you do? They're more interested in the person and having a conversation about who they are. Whereas in America, to a lot of people, what you do and how much you're worth are who you are. And so you get used to describing what you do in an interesting way so that you can continue a conversation. And so that whole idea of speaking about yourself becomes part of your normal social interaction. And to Ram's point, getting used to doing that is it's a massive transition. And maybe what you should try, Nick, is just reverse psychology. We were thinking about having you on, but we're not sure that you're up to it. We're not sure you've got any new ideas. We don't know whether you've actually got any. Are you actually doing any manufacturing? Are you,
Simon, are you busy at the moment? I need some help.
We can talk about it.
Yeah, because
we can talk about it.
Did our kids go to school together in Washington? They did, didn't they?
Yes, they did. Yes.
Yeah.
That's where we met.
At the British school in Washington.
That's right. That's where we met. Yep.
Yeah. That was a long time ago, folks. Yeah, but anyway, who said
Nick had hair.
Adam, was the be visible to be viable actually takes us right back to the start of this hour when I talked about the need for manufacturing to be visible in order to be viable. And that is a fabulous quote. Did he originate it, or is it quoting
as far
somebody
as I'm
else?
aware, he did. Paul Horn. He does creative visual screens for advertising and stuff. But I'm mis-selling him here. He's the creative side of the sales, and he coined it as I'm a big assumption there. I shouldn't do that, but he started using it through COVID, and that's how it's become known in our group for that.
Fantastic. No, it's that visibility equals viability. I mean, I shall use that in my shameless attempt to drag manufacturers in front of a camera. Listen, thank you, everybody. It's coming up to 7, and I really, again, love these chats. Thank you so much. I hope those of you who are new to it have enjoyed yourselves. John, thank you very much for coming in from Proto Labs. It was a great pleasure to have your company on the Manufacturer of the Week this week. Great stuff. Had to be dragged in, of course, by the PR and marketing side, and maybe that's it. It's the marketers and the PR people who understand all of this stuff. Stephen, Simon, Richard, Alec, Angela, Steve, Ram, Roy, Adam, bless you. Thank you, everybody. I'd love to have you back next week. I'll keep sending out emails, and we'll look forward to seeing you again very soon. But thank you again, and cheers for now.
Bye-bye, everyone. Have a good weekend. Bye-bye.
Have a good weekend.
Thanks, everybody.
See you later.
Bye-bye, everybody.
Cheers.
Oh, and by the way, the chat has got the Tristan's link in it. It's worth having a look.
Yeah.
Cheerio for